PowerShell scripting, creating basic parameterized scripts. Now, at its simplest form, a PowerShell script is really just a text file that contains a command, perhaps that you've already tested in the shell to make sure it works. What makes a script more reusable, though, is if you can take some hard-coded values from your command, maybe the computer name that it contacted, and parameterize that information. That way the command can stay relatively unchanged, but when you run the script, you can kind of modify its behavior, have it talk to a different computer, for example. This is the very, very foundation of scripting. Pretty much everything we're going to do from here will build on this idea to make it further refined and more functional. In this nugget, we're going to kind of kick you off on the scripting path. We'll start by testing a command right in the console. I always like to do that because it's a quick way to see if it works or not. And then we'll add that command to a script. We'll go through and we'll identify the changeable pieces of information and then parameterize those so that we can run the script without ever having to get in and edit it. All the information it needs to run we'll provide through parameters. Now this stuff has been the same since PowerShell version 1 came out, so I'm just going to open up the ISE here in PowerShell version 2. I really hate the version 2 ISE. I've changed my mind. I'm going to do this on my Windows 8 computer. Everything here is the same in version 2, 3, it doesn't matter. So let's just go to the console and run a command. What's something that folks might need to run? Let's see here. How about get wmaya object. We'll grab Win32 logical disk. I really only want to grab the ones where the drive type is 3. Those are my local fixed drives. Okay. Free space is in bytes, size is in bytes. Not thrilled with that. Let's pipe that to select object. And I want to grab, well, I want device ID, but I'm not particularly wild about it being called device ID. And I wonder if, let's just select all. I wonder if there's a PS computer name property in here that would have the computer name. There is. That would only exist in version 3. You can also grab __ server, and that'll exist in any version. So let's keep this compatible. I'm going to do one of these little fancy things because __ server is pretty ugly. Let's do this. We'll set this to __ server. So that'll give me a normal computer name column. We'll do the same thing, and we'll call this drive instead of device ID. So you can kind of use these little custom properties here to get the output looking the way you want it to look. And then for free space, I'm going to put that in gigabytes because I don't think anyone cares about free bytes anymore. So the expression here is going to be whatever was in free space divided by 1 gigabyte cast as an integer. That'll drop off any fractional portion. And we'll do the same thing for size. Name equals size in gigabytes. And the expression is $_size divided by 1 gigabyte as an integer. Now, let's see if that worked. Oh, good, it did. Now let's see if we can fire that off against a different computer. Always test with the local computer first. It's just faster. And we can stick a computer name parameter in here. See if it can hit my DC. Oh, and you know what? Just putting the NetBIOS name is going to take this a little while. Because my client computer happens to be dual homed. Really should get in the habit of putting the fully qualified name on there. We'll just let this run, see if it works. Okay, no, that's fine. It worked. It got me the information I needed. So I'm just going to take this whole thing now and select it onto the clipboard. I don't need the shell anymore, so we'll minimize it and get here into the ISE where I can paste all that. Now I need to get rid of the prompt and I need to get rid of the carriage returns so that this thing runs as a single command. And this is where I also kind of would like to make this a little prettier. I'm going to use the complete command name and I'm going to make sure I specify actual fully spelled out parameter names. Why is that not tab complete in class name? I don't know why. Class. And then after the pipe character, I'm going to hit enter. And then, this should be select object, and then that's the property parameter. And after each comma, I can actually hit enter again. And I can kind of line these properties up that way. They'll look a little bit nicer. There's the other one. Look a little nicer. I think it just makes this easier to read. Okay, having done that, let's immediately save this. And I'll just put it in the root of my C drive so it's easy to get to, and we'll call it get disk info. Now, you can test here in the ISE. I can run this just like this. Of course, it's still running against my DC. One thing that I like to be a little bit careful about when testing in the ISE is that it does behave a little bit differently. How it manages its run space memory is slightly different from how the console does it. And so sometimes it's possible to get different results in the ISE than you would get in the console application. So there's that. Let's come back here and change that to the full name. So I like to always go down into the console and test these things too. And that was called get disk info. So let's just run it there. And you see with the fully qualified name, it happens much faster. All that did is it tells me that my process of copying and pasting the command and then reformatting it didn't break anything. And that's important. One step at a time will help you prevent bugs. If it didn't work now, then clearly it was just some sort of typo that I did. Maybe I don't have a comma at the end of the line or a pipe or I hit enter in a weird place like that. So just make sure everything's good. Now what we need to do is go through and look for changeable information. Now the one piece of information that's obviously changeable here is the computer name. So let's create a parameter block. Now you can string your parameter all out on one line. I'm actually going to build it into a little block here because I just think, again, it looks a little neater. Because I'm inside these parentheses, I'm going to indent one character. You notice how I indented lines 6, 7, and 8 so that these @ signs all lined up so that each of these is a single property in the property list? Kind of the same idea here. Indenting tells me what information is actually contained inside these parentheses. So I'm going to specify that the computer name is a string by putting the word string in square brackets. PowerShell is not case sensitive, but it will pay attention to the casing you use. By using a nicely cased computer name like this, it's going to show up nicely elsewhere. So what I've done here is I've defined an input parameter. I've said one of the pieces of information that this script requires to run is computer name. That creates $computer name as a variable inside my script. So I'm going to copy this to the clipboard, and I'm going to use that in place of this hard-coded computer name. Now there's other information here that might be changeable as well, and maybe it's the drive type. Now I know that's supposed to be a number, so I'll declare this as an integer, and I'll put drive type, copy it to the clipboard, and use it in place of this hard-coded value 3. Now the fact is, if I'm looking for disk info like free space and size, I'm probably only concerned about my local disks. So I don't want to have to specify the drive type as 3 every single time. So in the parameter block, I'm going to define that with a default value of 3. Notice that I have a comma after the first parameter, but not after the last one. That's because these are designed to be written all up on a single line like this. And so the comma actually provides the break between them that tells the shell, here's the first one, here's the second one. I like to get them on a line by themselves, think it looks prettier, but you still need that comma in there so that PowerShell can tell the difference. And if it makes sense for you to have a little space in here before the comma, that's cool. PowerShell should be totally fine with that. One mistake you'll see folks make is they'll start to confuse their punctuation. And you'll notice I have an open parenthesis and a close curly, and you see that little red squiggly? If you hover, it's saying, hey, I saw a closing curly bracket. I don't know why I saw that there. Please don't do that. That just tells me that I typed something wrong, so I can go back and figure out what it is. Notice too, when you put your cursor right next, this is tough to see, so you may have to zoom in. When you put your cursor next to an opening like that, the ISE is highlighting the opening and the closing one. Here's why that's useful. Let's say I forgot to type this one. Now right there you see the little red squiggly show up, and he's saying the hash literal was incomplete. Each of these is called a hash table, each of these things with an @ sign, and it knows that I've not got the same number of closing brackets as I do opening brackets. Well, here's how that little cursor highlighting trick can help. See, this is telling me that well, actually, I guess I can draw this for you if I want to, can't I? The highlighting is telling me that this closes this, and that's correct. That seems accurate to me. That's what it's supposed to be doing. So we'll put it next to that one. So there's my integer. That one's closing that one. That's good. So we'll go up to the next one. That's closing that. Good. That's closing that. Good. That's a... Oh. No, see, this it thinks is closing this, which is why that is missing. So I need to put another one there. Now the last one closes the first one, and this nested set does. So that highlighting can really help you figure out those problems. So I've defined two parameters, computer name and drive type. I've used those placeholders instead of their hard-coded values, and I'm going to save this. And when I hop down to the command line here, I'm going to run get-diskinfo. I'll hit tab for tab completion. I want to show you something. By default, all of your parameters are positional. So in my script, I defined computer name first, so I can put the computer name first. And drive type I'll specify as 3. I don't have to specify the drive type. It'll default to that. It still works. Here's what's cool though. I called the parameter computer name minus tab. See, it's tabbing through the parameters I provided. If I didn't do that, if I did like minus C, it would know that that's the only one that matches. And then I can put dc.lab.pri, drive type, oops, if you hit tab there, it tries to fill in file names. Don't want that. Drive type 3, works. Try it without the drive type, works, defaults to 3. So this is really simple. It's not really programming in a way that anybody would call programming. I've just taken a command that was running just fine in the shell. I neatened up the formatting a little bit, and that's something that we're going to talk about in a little bit about best practices. I can't help myself. I like the formatting to look neat. I defined a parameter block, and I put 2 parameters in it, each one separated from the other by a comma. I've given each of them a data type. Now there's a reason for that, and it's so that if I accidentally try and provide the wrong type of data, PowerShell will know. For example, computer name, that's a string, drive type, fixed. Immediately gave me an error. I can't do that on the parameter drive type. I can't convert that value of a string called fixed to an integer 32. So by telling PowerShell what my data type is supposed to be, it can actually help spot incorrect data coming in before my command even tries to use it. Once I define those parameters, they become variables inside my script, and I can use them anywhere in the script just as any other variable. They'll contain whatever value was passed to the parameter. Then I get my output. Now, the neat thing about this is I can take the output of that script. Let's see if this will work. There's the working version. I can pipe it to format table, auto size. I can pipe it to export CSV disk info. The output of my script is just like any other PowerShell command output, and so it can be piped to other commands. I can format, I can export, I can convert to HTML. What I've done is essentially just run the command and allowed its output to go into the pipeline. Well, that becomes the output of my script. It gets written to the output pipeline and can then be piped onto anything else. So running the script is really exactly the same as just running that entire command manually in the shell. The script just makes it kind of easier. Now here's where this is useful. Let's say you wrote a command like this one and you wanted to give it to your help desk, just so they would have a quick way of retrieving that information. You'd say, well, all right, I'm going to just put this in a text file for you. And before you run this, make sure you go in and change the computer name. I mean, don't type over the word computer name. You want to... Asking the help desk or someone with less technical expertise to edit this might not be a good idea. There's an awful lot that can get messed up, and this punctuation is really, really picky. But I don't have to worry about that because I've put it into a parameterized script. They don't have to edit anything. They just have to run the command and provide the parameter. And it works perfectly. This is cool too. Oops, I need to provide a little bit more than that. Disk info. There we go. If you ask for help on the script file, PowerShell will actually read that parameter block and tell you you need to provide a computer name, and it needs to be a string, and you need to provide a drive type, and it needs to be an integer. Pretty cool stuff, right? Now, right now, if they try to run this without specifying anything, they're going to get an error because computer name is empty. WMI object is trying to query from an empty computer name because that's what's in the parameter. Now let's try this. I'm setting the default of computer name to a parenthetical command. We're using read host. Now look what happens. If I run my command and I provide a computer name, then there's no need to use the default, and so that's the computer it will query. But if I try to run it and I don't provide a computer name, it will use the default, which executes the read host command. Member probably has his firewalls up in full mode too, so this will fail. But that allows me to specify an alternate. It allows my script to be a little bit intelligent. If someone tries to run this and they haven't read the help and they're not quite sure what to do, it'll prompt them for the computer name. And that's the one important piece of information that the script needs to run. RPC server unavailable, of course it is. Let's try it again, and we'll do dc.lab.pri. That worked. Let's try it again. We'll do win8.lab.pri. Win8 might also, that's this computer, he might have his shields up in full firewall mode too. Yep, he does. How about client? Yep, he worked. So I think this is a really, really great approach to use as you start getting into scripting. Again, we're not really programming. We just took a command, we parameterized the information that needs to change, and we put this param block up at the top so that PowerShell would know what information to expect from whoever is running the script. Once it has that information, it just runs the command using those pieces of information. Notice here how I used the little double quotation mark trick so that the variable drive type will be replaced with its contents, so that I didn't have to concatenate strings together. You can just stick that variable right inside the double quotes. Here I didn't need to do it because I don't have to have any text in addition to the computer name like I needed to over here for the filter syntax. So again, great approach. I think this is definitely the first step you should take as you start scripting inside PowerShell. So you can see that the process of getting from a command to a parameterized script is actually not that difficult. I showed you how to test the command, and I love to do that first in the shell. You get immediate feedback. Test it against real values. Then you can copy and paste it into a script. Fix up the formatting a little bit, obviously. I also like to take the step of making sure that all of my command names are spelled out, no aliases, and that I'm using named parameters for the most part. I don't like to rely on positional parameters in a script. I just think that named parameters make the script easier to read. Then you go through and you identify changeable information. What might need to change each time you run the script? Computer names are an obvious choice, but there's obviously others. And then you parameterize those changeable bits, simply adding a parameter block to the very top of your script. You can then test the script, make sure it works the way you want to. I hope this has been informative for you, and I'd like to thank you for viewing.